So hey guys, today we are going to solve graph questions on the topic current electricity. So coming to the first question, from the graph below, identify which portion corresponds to negative resistance. So it is an IV graph and we know that the slope of this graph will give us the resistance. So whichever portion of this graph is going to have a negative slope, that will correspond to negative resistance. So from this graph, we see that CD portion is having a negative slope and therefore it is going to have negative resistance. The answer is CD. Now coming to the second question, the graph shows the figure shows the graph between I and V for two conductors A and B. Their respective resistances are in the ratio. Okay, now we are going to solve this question using Ohm's law, where according to Ohm's law, we know that V is equal to IR. Then if we write V by I, that will give us equal to R. But since it is IV graph, we are going to write I by V. So I by V is equal to 1 by R, which will give us tan theta. Alright. Now if we are going to find the resistances ratio, let us start by writing 1 by RA, which will be equal to tan. For RA, we are going to write the theta as 60 degrees, which will be due to 90 minus 30 degrees. Okay, so it will be tan 60, which will give us root 3. Now if we are writing what is RA, that will be 1 by root 3. That's it. Now if we are going to write for conductor B, which will be 1 by RB, which will be tan 30, and that will be 1 by root 3. Hence, RB is going to be root 3. Alright, now if we are going to find the ratio of RA is to RB, which will be 1 by root 3 is to root 3, that will give us 1 is to 3. Now let us check our answer. Yes, the answer is 1 is to 3. Now moving on to the third question. When a current I is passed through a wire of constant resistance, it produces a potential difference V across its ends. The graph drawn between log I and log B will be. Alright, so we are going to use Ohm's law here once again, and we'll also use a little logarithmic here. So we are going to write V is equal to IR, and taking log on both sides, that will give us log V is equal to log I plus log R. Alright. Now if we are going to write them according to this Y is equal to mx plus c, we need to rearrange them according to y and x. So from this graphs, we tend to observe that on the y-axis it is log I, and on x-axis we are having log E. So now we have to write log I is equal to log V minus log R. Okay, now M is positive, that is the slope is positive, and the C part is negative. Okay, so from this information, we can draw the diagram or the graph to be like this. That is, it's going to have a positive slope which meets the negative axis like this at this point. So from these graphs, we can see that option A will be the answer. Now let us check this. Yes, the answer is option A. Now moving on to the fourth question. The resistance RT of a conductor varies with temperature T as shown in the figure. If the variation is represented by RT is equal to R0 times 1 plus alpha T plus beta T2, then the signs of alpha and beta are. Okay, so we have to simply find whether alpha and beta will be positive or negative. Now on observing this graph, we are seeing that it is a positive parabola. Since it is a positive parabola, where it will be positive here as well as here, that is from the x-axis as well as from the y-axis, we tend to say that the signs of alpha and beta is going to be positive only, since it is in the first quadrant. Yes, the answer is correct. Moving on to the fifth question. The VI graph for a conductor makes an angle theta with V-axis. Here V denotes the voltage and I denotes current. The resistance of conductor is given by. Alright. Now let us start plotting this graph. For our convenience to show the theta angle with V-axis, we are going to take this IV graph, so that it becomes easier for us to see the theta angle. So we take this IV graph, and here is the theta. Now if we are taking a small portion of this, here also it will be theta only. Now from this graph, let us start writing our interpretation. We are going to write that tan theta is equal to slope of the line, which is delta I, which is equal to delta I by delta V. Alright, and we know very well. See, the question is, we have to find how the resistance of the conductor is denoted, okay? So we also have to use a little Ohm's law here. So R is equal to V by I, okay? Therefore, tan theta is equal to 1 by R. Remember guys, like how we saw in the previous question. Therefore, R is equal to cot theta. Now let us check our answer. The answer is option D, cot theta. Moving on to the sixth question. In an experiment, a graph was plotted of the potential difference V between the terminals of a cell against the circuit current I by varying a load rheostat. Internal conductance of the cell is given by. Okay. We have to think it in terms of y and x. So, let us start by writing this. We know that x is going to show us the potential difference and y is going to show us the current. Alright. Now if we have to write the conductance of the cell, where conductance is nothing but 1 by R, we can easily find that. We know that it will be 1 by R will be equal to I by V, which will be y by x. Now let us check our answer. Yes, the answer is y by x. I hope you understood. Thank you for watching.